Hi guys, as part of today's lecture, we will get a basic understanding of how to use the PSoC creator software and the different design steps that we need to go through to successfully complete a project. So, as part of today's lecture, we will first go through the basic steps for using PSoC creator. Then we will get started with the design. We will look at the basic concept of digital outputs. Then through lab 1, which is today the blinking LED lab, we will understand the programming of a PSoC device. Before I get started with the basic steps, I would first like to explain today's lab, which is the blinking LED lab. So as part of today's lab, we have the PSoC device, which is a PSoC 4, on an existing board, which is the 042 Pioneer board that we are using. So on your board you have a tri-colored RGB LED. So we have the R, the G and the B with a common anode. So this is connected to VDD. So what we would be doing is we will be using the PSoC 4 device to connect to the R component of the LED. So effectively, if this is my device, I have the LED connected as follows. This is VDD. So if I give an output 0, then the LED will glow, and if I give an output 1, then the LED will not. Typically when you connect an LED, please remember that you would always have a resistor and then connect it to either ground or VDD. So this resistor is already connected on board here, just as an additional info for you guys. So in today's lab, we will have a pin that we will call LED as part of our design, and through the microcontroller we will first write an output 0, then we would write 1, then we would write 0, then we would write 1, and then we would make the LED blink. Okay, so now let's go ahead and look at the design steps that we need to follow. The first step that we would do is we would select the target device. In our case, for this lab, we are using a PSoC 4 device. Then we would start with the schematic entry. After the schematic entry, in which we would select the components and the pins. Now in today's lab we don't have any components as such, we just have the microcontroller and we have a pin here. Then we will configure the components and the pins. Again, in today's lab we don't have any components, we just have a pin. Then we will map the design pins to the physical pins of the PSoC chip. We would do the microcontroller programming, we would build the design, then we would program the PSoC device, and depending on the output we would test and debug the design. Okay, again I'll revisit these points as we are doing the experiment. So let's go ahead and look at the PSoC creator software. So this is the PSoC creator software. First you have to go ahead and create a new project. Now you have to decide whether you're going to use a PSoC 3 design, PSoC 4 design and PSoC 5 design. So on the board here, since we have a PSoC 4 device, so here on the software we will select an empty PSoC 4 design. Go ahead and name the design as lab 1 underscore LED. make sure that you have the folder named correctly. And then click OK. So this is the project workspace for your design. On the left hand side is your workspace explorer. In the middle is your schematic sheet where you will be adding the components from the component catalog. Go ahead and take some time to explore all the components. Now, a small point that I would like to make here is that depending on your target device, so this device is a CY8C, CY is Cypress Semiconductors, 8C is PSoC, 4 is PSoC 4, and depending on your device, so whatever device you have selected, only those components will you be able to view here. Now if you want to go ahead and change your device, right click on this and click on device selector, and you can choose your target device right here depending on whether it's a PSoC 3, PSoC 4 or PSoC 5 LP. That said, we are back to what we were doing. Now in today's lab we just have a pin, we don't have any component, so go into the ports and pins section, and since we have an output, we will be selecting a digital output pin and dragging it onto your design. Go ahead and zoom in so you have your pin here. Now any digital pin can be controlled by two methods. Let's go ahead and view this conceptually. If I have a digital pin, I can either directly control it from the microcontroller using an API or application programming interface. So you have some functions, API functions, using which you can directly control this port or pin, or if there is a hardware component, for example you have a flip-flop or a register, you can then control this hardware component using the microcontroller, and in turn this hardware component will then supply the value to the pin. So there are two possible options, remember that. And in the software, how do we do that? So step number one, as we said, that we selected the target device. Step number two, we selected the pins. In this case we don't have any components. Step number three would be the configuration. So go ahead and double click on this, and the configuration window will open. Another way of doing that is if you right click, you can click on configure. Now since this is an output pin, if you want to know about the APIs and the softwares, please go ahead and click on Datasheet. Now the datasheet will give you all the information about the different API functions and all the information about these pins. So this is what the datasheet looks like. You can have all the information about, you can display the pins as a bus, you can display them as a component, you can have analog pins. So all the information is here. You can have the API functions, so go ahead and click on application programming interface. Now depending on what you would like to do with the pin, you can select that particular API function. In today's lab, we will be writing the value 0 or 1 to that pin. So we will use the API pin underscore write. So I have to give an unsigned integer 8 value. So depending on what the name of my pin, so it's the name underscore write with a uppercase W and the value. So we'll use this API today. In the next lab, we will be understanding the use of the read function. That said, let's go back to the software. So let's name this pin as LED, and I'm using the name R because it's the red LED. Now, as I said, that you could have two ways of controlling this pin. Either it's through the microcontroller or through the hardware component. Since I'm going to directly control this from the microcontroller using an API, let's go ahead and uncheck this so that there is no hardware connection. And that should be okay for now. So go ahead and click on OK. So we finished step numbers 1, 2, and 3. We've configured the components and pins. Here we don't have any components. In lab number 3, we will have components, but we did configure the pins. Now we need to map the design pins to a physical port or a pin on the PSoC chip. So let's see what we have to do there. So if I need to visualize this, let's assume that this is my PSoC chip where I have my microcontroller, and in my schematic I used a port or pin called as LEDR. Now the physical pin which is connected to the R LED is connected to a particular physical pin of my PSoC 4 chip. So how do I know where this LED is connected? For that, you would need to access the datasheet of this particular board that we have here. This is called the PSoC 4 Pioneer board. So let's go ahead and find out the datasheet for that. So this is the web page for the PSoC 4 kit. Let's go ahead and download the PSoC 4 starter guide. So let's go ahead and download this particular PDF file. You can right click and save the PDF file onto your PC. So after you've downloaded the PDF file, go ahead and take a look at the guide. It has the basic steps towards the installation, the kit operation, the hardware, code examples. There are a few examples given, and then there are some advanced topics as well. So let's go ahead and look at the LEDs. Now there are a few LEDs on board. There are 3 which are combined into one RGB. Those LEDs are connected to P16, P02, P03. Now the R is connected to P16, the G is connected to P02, the blue is connected to P03, and then the common anodes are then connected to VDD. So since today we will be using the R LED, So we will be focusing on P16. Now, as I said, we need to map the design pin, which is LED R, to the physical pin, which is P16. So we will go ahead and double click on the .cydwr file, and here go ahead and enter the port, which is P16. So now LED R is mapped to P16. Now CYDWR stands for CY Cypress. DWR is device wide resources. So all the resources that are there on my device, you can take a look at them here. You can look at the analog section, then you have clocks, you have interrupts. Now in the analog section you can take care of the routing. Again, this is a slightly specialized section, so at a basic level I would not recommend playing with this particular region. You have the clocks here, so you can select which clock you want. You have the interrupts. Since you're not using any interrupts in this design right now, we don't need to look at that. And then you have the system level issues, you've got the other directives, and then you've got the flash. Again, please be careful about the flash settings. Right now we will just look at the pin assignment. So let's go ahead and look at the next step, which is the microcontroller programming. So double click on the main.c file. So now, since we are using the APIs for the pins, we must include another header file, which is #include cypins.h, and here we have the main function. This is my infinite loop. So first what I'm going to do is I'm going to use the API. Since the name of my pin is LEDR, so LEDR underscore write 0. So I'm turning the LED on. Just as a comment, I'm putting turn LED on. Then I give a small delay, so now I'm using a delay function, which is cy delay, and the input is in milliseconds. So let's say 1000. So 1000 milliseconds would be 1 second. So delay of 1 second. Then I go ahead and turn the LED off. So LED underscore write 1. I turn my LED off, and again I give a delay of 1 second. So this was a fairly straightforward program. So this was my step where I do the microcontroller programming. Now let's go ahead and build this design. So here we'll do clean and build lab1 underscore LED. Now in your output window you will get the output depending on whether there is an error or not. So it would go through all the different steps of the digital, analog, placement, routing, all of the above, and finally it will look at the software part, which is your C code, and if everything is fine, then it would say that the build would succeed. And it says that the build succeeded. So from the design aspect, everything is fine. Now we need to look at whether this works on the hardware. So let's look at the board. Again, this is your PSoC 4 device with the PSoC PHY, which acts as a programmer from your PC. So you would have received a USB cable which looks like this, and go ahead and plug this part of the USB cable to the port here, and the other part, which is this, goes to your PC. Now your PC might take some time to recognize and install the driver software for the kit programmer. Now in case you're using the Windows 8 operating system, and if your PSoC 4 board is not detected, then I would suggest that you go and update the PSoC programmer software. You need to download the latest version of PSoC programmer. This is in case you're using Windows 8. Again, if you have problems with PSoC 4 and Windows 8, there isn't a problem, but in case if you do, please download the latest version of PSoC programmer. You can do that from the Cypress website. So once that all the driver softwares are downloaded, so now your board is ready to be programmed. Now keep an eye on the board here. This is your RGB LED. So now on the software, let's go to debug and then click on program. And now if we look at the software here, it says that programming of flash has started. And now let's look at the board. If you see that the LED is blinking and the R LED. So now let's go ahead and do a small exercise. Instead of, let me keep the on time as 3 seconds and the off time as 500 milliseconds. Let's go ahead and program the board again. Let's keep an eye on to the board here. So now we'll see a change in the on time and the off time. Now you see the on time, the off time. So the on time significantly increased as compared to the off time. Now let's reverse this. Let's make this 500. Let's make this 3000. So the off time is more than the on time. Again, I would go ahead and program. Look at the output window. It then starts programming the device. Let's look at the board. Now see, the off time is more, the on time is significantly less. So this is an interesting exercise. Now as part of another lab, let's try something different. So now at the end of this lab, we looked at how to blink an LED. We saw all the basic design steps for using PSoC Creator. In the next lab session, we will see a small extension to today's lab. I shall see you in the next lab session. Thank you very much.